Alright, so today we're going to talk about negative exponents. We're going to look at how to apply the rule. Now, this rule is the simplest to see and understand and to write, but it's probably the trickiest overall to explore and to apply. So listen real carefully, take real good notes on your notes, and we'll be able to work this through. So the negative exponent law starts out when you might have a problem that looks something like this. 3x to the negative fifth, or x to the negative 2. So to go back and kind of look through this, I'm going to go ahead and show you the negative exponent law first, and then we'll talk about how to apply it and take a couple of examples before we jump into the notes. All right, so the negative exponent law looks simply like this. For a number x raised to any negative exponent, when you simplify this, you take 1 over x to the a power. So in this case, really what we're looking at when we apply the negative exponent rule is we think about in terms, it's really the reciprocal of the overall number. We take the reciprocal of that number, of the initial number. So it's 1 becomes over 1, x switches places, and the a switches to its inverse of positive a. Because really what a negative exponent is, if you've ever taken a look in scientific notation, it is a number between 1 and 0. So a number that is less than 1, but yet greater than 0. So that's really what we're looking at. So just to give you an idea, what's commonly used for negative exponents are scientific notation rules of something that is smaller than the eye can see, or smaller than, say, an inch or 2 or 3. You really can look at like an atom of oxygen. While there are trillions of them in the room you're probably sitting in, you still can't see them because they're so small. They'll be written with this idea of a negative exponent. Okay, and when I switch it from x to the negative a to 1 over x to the a, you can see how this turns it into a fraction which is less than 1. Now it's greater than 0, but it's less than 1. Because if an atom of oxygen wasn't there, you wouldn't be breathing. So we know they're here, we just can't see them. So let's now apply the rule. Let's take a look right here. So then I'll show you one other way to kind of help you explain and see what a negative exponent is. So if I take this number, what it means is I take the reciprocal. So if I'm starting out with x negative 2 over 1, I switch it to 1 over x squared. And that lets me simplify. This next one's a little more challenging because it's got two numbers. It's got the coefficient of 3, and it's got the base and exponent pair of x and negative 5. Now, this is the part that catches a lot of students. When you go ahead and do this, the exponent on the 3 isn't negative 5, it's positive 1. So that number isn't negative, so it's not going to move. So it's going to turn into 3 over x to the positive 5. Okay. Now that we've kind of seen how it applies and seen what it looks like, I'm going to go ahead and show you one other way to kind of get a good head start on this. So in one of the previous videos, we've talked about how the powers are another way to write our place values. So 1,000 can be written as 10 to the third. 100 can be written as 10 squared, and 10 is written as 10 to the first. Just another way to think about this: 3 zeros, exponent of 3, 2 zeros, exponent of 2, 1 0. And then we talked about the other day that when it's 1, it's written as the exponent of 10 to the 0 power, because it's a 1 with no zeros. Okay. Now the other side of that, this is all to the left of the decimal, but over here to the right, there's still more place values. The first place value is 1/10. So another way to think about that's right here. Well, I can take this and turn it into a fraction over 10, or I can write it as a negative 1. So if you think of these as positive, that means they're going to the right on the number line. This is them to the left. Left 1. Look, I moved my decimal place. I'm to the first place left of it. where now I've got 1/100th. I can write it as 1 over 100. And that simply looks like 1 over 10 squared if I take this information. And then the other way to write it is 10 to the negative 2. All of these are different ways to kind of look at a negative exponent. So let's take a few minutes and start exploring this. So we start out here with a simple number, x to the negative 5. So remember that this is simply a reciprocal. So if I take it and I switch the locations, 1 over x to the positive 5. Now there's nothing I can do. There's nothing I need to do here. It's completely simplified because pretty much all of your homework from here on out is going to see this. Whether it's in my class or Algebra 2 or Geometry or any math class you take, they're only going to allow you to write your answer in positive exponents. So be real careful that if you have a negative exponent anywhere in the problem, you can't use it. So let's take a look at the next one. So the next one is just like that other example we have. We have a coefficient and we have a secondary base. So the base, the exponent pair, has that negative exponent, m to the negative 2. But the 3 has a positive exponent of 1. So that leaves me as 3m squared. Now here's the other thing that catches a lot of students. Negative 7, a to the negative 4th, b to the cubed. So a lot of students go, oh, it's a negative number. Negative numbers must have negative exponents. And that's just simply not true. A negative number still has that positive exponent of 1, so it's going to stay in the numerator. The a to the negative 4 is going to switch places, and it's going to flip from the top to the very bottom. And b cubed is going to stay where it is because it has that same positive exponent. Now let's take it up a notch. Let's take a look at a number with an operation attached to it. So we have multiplication. So the product rule says we multiply the coefficients and then we add the exponents. One thing you have to remember at the very end is the last. We've been working through this concept of making this is that the negative rule applies last. So we've been taking a look in class at our organizer has always been based off of the order of operations. And we've taken a look at how powers multiply, multiplies add, divide, subtract. There's nothing below add or subtract, so you do nothing with the exponents. But what you don't see over here is the negative. So the last thing you do after you add or subtract, you're going to apply that negative rule. Okay, so you apply the negative rule last. So I'm going to put a little note for you. Maybe you'll be able to see it this way. There we go. Apply negative last. Rule last. It's important you remember that because if you don't, you might end up like on this current problem we're going to take a look at, is that this number is actually going to get rid of the negative. So if I do 6 times negative 3, I get negative 18. But now my product rule jumps in and I go 8 minus 7, or 8 plus negative 7. Well, 8 plus negative 7 is positive 1. So now I no longer have that negative I have to take into account. I have my positive exponent. Let's take a look at it with the power rule. So the power rule says we distribute. We distribute that negative 2 to both numbers. So remember the 1 on that thing. So this becomes 3 to the negative 2 power and x to the negative 6 power. So I do want you to write this step. It's steps important for you to know and be able to use so that if you are combining them or you're going to go ahead once you do the power rule and do another step of multiplication or you're adding and subtracting, you have that part versus jumping right to applying that rule last. Okay, so now that we have this step, we can go, okay, there's no other operations. Let's apply the negative concept. It becomes 1. 3 to the negative 2 becomes 3 squared here. And x to the negative 6 becomes x to the 6. Now are we done? You know, when a teacher asks that question, you're never done. So we can still simplify 3 squared. So our final answer turns into 1 over 9x to the 6th power. When it's negative, I can't square it. The other thing that common mistake students make is they go, oh, it's a negative exponent, therefore my coefficient will turn negative. And that's not true. The negative exponent just tells you to put it in the denominator, not it doesn't tell you anything to do because once I get it to the denominator, as you can see, it turns into a positive exponent. And then we can work with it like normal. So what I want you to do is pause the video and complete 6, 7, 8, and 9, and we'll go ahead and take a look at them when you're ready. All right, so now that you've got those done, let's take a look at them. So again, I'm going to distribute. So I get 5 to the negative 2 and y to the negative 4. So it's just like that previous problem. I'm going to get 1 over 25x to the 4th. And then I'm going to go ahead and work on this next one. So distribute my negative 2 every time. So I have negative 8 to the negative 2 power, x to the negative 10 power, and y now is no longer negative, it's positive. Okay, so now I work through my problem. So now y to the 8th is going to stay on top because it's not negative. And I'm going to switch negative 8 to negative 8 squared, and negative 8 squared is 64 because negative 8 times negative 8 is positive 64, x to the 10th. Okay, let's take a look at these next two. So these are both of the product rule. So this one just uses the product rule. So now I'm going to add my two numbers. Negative 5 plus 7 gives me a squared. 8 plus negative 3 gives me b to the 5th. And negative 12 plus 7 gives me c to the negative 5, which I know is just going to move it to the denominator. And there's my final answer. Now this one is a multi-step problem. It has both the power rule and the product rule. So we start by distributing. Just like the order of operations says, I handle all my exponents before I go into multiplication. So I have x to the negative 4, y to the negative 6. Then we have times x to the negative 15, y to the negative 12. Now I add my numbers together. Negative 4 and negative 15 gives me x to the negative 19. So x to the 19th is in the numerator. The denominator, I'm sorry. Negative 6 plus negative 12 gives me y to the 18th. And then I need a placeholder up here, so it becomes 1. All right, good job. Now let's take it up one more step. So now we've got even more problems. Okay, in this case, we're going to start here. We're going to go ahead and apply it with addition, subtraction, take one more look at. And then I'm going to explain a little bit about division and let you guys get a head start on it. All right, so let's go ahead and take a look at this one. So I've got the power rule, so I'm going to go ahead and distribute every time. Same in here. So I'm going to finish my distribute. So I get 4 to the negative 2, x to the negative 6, y to the negative 12. Over here I get plus 2 to the negative 3, x to the negative 6, y to the negative 12. So now the reminder is that all of these have to be exactly the same. If they're not, they can't work. So first thing I'm going to do is go ahead and apply my negative rule. Now I know addition normally isn't here, but I'm going to go ahead and apply it because now I need to turn these into positive exponents, into real numbers, and simplify those before I can get it there. So these would both turn into 1, and this would turn into positive 16 over x6, y12 plus 1 over 8 x6, y12. So I'm going to go ahead and add these. I've got the same idea, so I end up having 1 over 24 x to the 6th, y to the 12th. All right, now let's take a look in division. Now division I actually really love because it allows me to see a picture. So if I think about this one, if I follow the quotient law, it says 4 minus 6, which leads me with h to the negative 2. H to the negative 2 then has to be simplified to positive exponents. It becomes 1 over h squared. Or I can draw it out. This one's really easy to draw and take a look at. So I'm going to just write x's, they're faster to do. X over 6 x's in the bottom. That's the factored form of both of those numbers. you know that you can cancel out the same number over top of each other, they're turning into ones. But now if you take a look at where are the x's, the extra x's this time, versus our last lesson where the quotient where we had the x's on top, now the extra x's are on the bottom, and that leads me right to that answer, 1 over h squared. Let's take a look at number 12. Now number 12 has got a negative exponent in the numerator. So what the rule applies is it's now negative 2 minus 7. So negative 2 minus 7 equals negative 9. That leaves me as k to the negative 9, which I then have to simplify over 1 over k9. All right, let's take a look at the same thing. So that gives us, so one of the things you've got to be real careful is that you always apply all of your rules in general. That negative 2 and negative 7 gives me negative 9, and then apply the negative law. Okay, and take a look at this next one. We've got coefficients, so we're going to handle those separately. 14 divided by 7 is 2. And then it becomes 4 minus negative 2. Well, 4 minus negative 2 is the same as 4 plus 2. So that leaves me now a positive number. Therefore, it's 2w to the 6th power. Now I no longer have a negative, and that gives me my final answer. I want to pause the video. I want you guys to try 14 and 15, and then we'll jump in and do a couple more in the last one. All right, now that you've worked those on your own, let's go ahead and solve them. Negative 24 divided by 3 is negative 8. X to the 5th power minus negative 2 gives me x to the 7th. All right, now my last one. B squared minus divided by b squared is 2 minus 2, so that just gives me 1. So I can pretend those don't exist. It's just like the previous example up here. Those cancel. C minus c to the 5th. So 1 minus 5 gives me negative 4. Leaves me with 1 over c4. Okay. All right, let's take a look at these last. Now these include negatives and different rules and all the different things to practice with your quotient rule. So let's keep working through this. I'll do number 17, and I'm going to ask you guys to do 19 through 21. And as always, the extra notes are posted on the topic page, and you can look at those to fill in anything extra. Okay? So let's take a look at number 17. A little bit more information, larger problem, still treated the same way. 32 divided by 8 is 4. 5 minus negative 2 gives me a to the 7th. Negative 3 minus 6 gives me negative 9, which puts b to the 9th right there. All right. Now that you kind of seen you're getting comfortable with this, you're going to be able to go through and instead of writing the negative exponent, you'll be able to move it right to where it belongs. So what I want you to do is try number 19 and 20. Pause the video, take a look at give those a try, and then when you're ready to check them, push play, and we'll get checking. All right, let's take a look at them now that you've completed them. 15 over 18. All right, so this one doesn't divide evenly, so I'm just going to have to simplify. The greatest common factor of both those numbers is 3, so that becomes 5 over 6. Now, a over a, they cancel, so those are gone. 5 minus 3 gives me b squared. And c8 minus 9 leaves me c to the negative 1. So leaves me a c in the final answer down here. There we go. Let's take a look at our last one. Negative 9 and 54, the greatest common factor of both those numbers is 9. So I'm going to simplify down to negative 1 over 6. Now, r squared and r to the 5th, so 2 minus 5 is r to the negative 3, so I'll put it in the numerator, the denominator. 6 minus 2 is s to the 4th. And t4 minus 8 gives me t to the negative 4. So t4 goes in the numerator. All right, so I'd simplify this one step further and go s to the 4th over 6r cubed t to the 4th power. All right, now that you've got that, you guys are ready to get started on your homework. Take your time. Remember to apply the negative law last, and you'll be in great shape.